So when we got together last time on Thursday for our physics part, I shared with you some Karen Allison collage, Fallen Leaves. Here it is, the first part of the song in French, just for those of you who might be missing France for some reason. Our conversation here is to talk about writing and organizing stuff. As a reminder regarding our schedule, today is the 26th of March, that's Thursday. Hopefully by Sunday, you'll have had not only my edits, but the edits from somebody else in class regarding your paper or your midterm lab report. That will be due the following Sunday by midnight, along with exam number 2. You're going to get exam number 2 on Thursday. And so my suggestion to you would be to spend Monday, Tuesday, Wednesday, making whatever edits you want to make on your paper so that it's ready to go before you have to be working on exam number 2. But our key points today are to be thinking about writing and editing. Let's talk about writing. I know we talked about this for those of you who were there on Thursday before classes ended, before spring break. But let's just remind ourselves of the process that's usually best in writing for a scientific paper. First thing, get your figures right. Make your figures and make them the way you want them. Because your figures are the things that are going to describe your entire paper. Second of all, organize your figures. Put them in the order the way you want. Third, once you've gotten your figures set, then simply write your figures. Introduce the figure. Figure X shows blah versus blah. Then, what does your figure show? The result is, what does it mean? This implies, and then repeat 1 through 3 for all of your figures. If you've done that, you should be able then to have the meat of your paper done. It is essential here that this stuff is all in basic, direct, declarative sentences. Nothing fancy. Once you've written around your figures, go back and do your setup, your experiment. You do your setup, I tell you what, instead really you should do your conclusions. Do your uncertainty analysis, and do your conclusions, which simply state what you found. Then do your introduction and your setup. Then put on your name and a title, and you're good to go. Most people run into trouble when they try to write this direction from the bottom, in which case you don't know exactly where you're going first. If you write with your figures first, after making them and organizing them, then it's simply a matter of telling a story that your data contains. Now, as far as editing is concerned, Again, there are a few basic rules. And really, they fall into a few categories. The first one is the English. The easiest thing to do is read your paper out loud to yourself. If you do that, you will find things that are wrong. If we're talking about grammar, read the paper backwards. Turns out reading it backwards, we we don't assume that we know the content. And so therefore reading backwards, we more easily see where we've made grammar mistakes. And I believe that's AR in grammar instead of VR. Um, the third one are figure details. Check for labels. Is it labeled figure 1, figure 2, figure 3? Is it labeled table 1, table 2, table 3? Check for titles. Is there a title in each figure or caption? Check to see that there is a caption telling us this. Each figure, if I photocopy it and put it off to the side and just look at that, should have enough information between the caption, the title, and everything else that I can immediately tell what's going on. If you can read your paper backwards, read your paper out loud to yourself, read it backwards, and check for your figure details, you're probably going to be in pretty good shape as far as the basics regarding your editing. Now, the other place where people run into significant trouble is in organization. In fact, organization, let's do that on a totally different new slide. Now, remember, let's talk about our forward organization. The idea here is that we have an intro, then we have body paragraph. In the body paragraph, we have a topic sentence, we have evidence, we do an analysis, and then repeat 2 and 3 as necessary. Then we go to the next body paragraph, the next body paragraph, and so on, until eventually we come to the conclusions. This is, in a forward sense, what we want to do. As far as editing is concerned, check your organization. What do I mean by that? Well, for each paragraph, find the topic sentence. Can you see it? If it's there, good. Identify what it says. Find the first evidence. Is it there? Good. Find the first analysis. Is it there? Good. Repeat as necessary. Notice what you're doing here, what this whole thing is trying to do. We'll arrange that and send it to the back. Is to check your organization by reconstructing it. If you find that you can't identify a topic sentence, if you find that you can't identify your first evidence, if you find that you didn't include a first analysis, If you find these things, then you know that that paragraph is probably not correct or complete. If you find that you don't have the concluding section or you don't have an introduction section, then again, you know that it's not complete. So this is almost like constructing um, an outline from the paper as opposed to constructing the paper from the outline. Use this as a way to check your organization. Now, the last thing to talk about that was regarding now in particular uh, comments regarding the lab report. There are a couple of common themes that I saw that are important. Theme one, label, title, and caption all your figures and tables. There are a number of people who didn't do this. Number two, your table should have column headers with units, and the data should have uncertainties. Number three, and this is the big one, many people either didn't have or didn't have a great uncertainty analysis. Now, there are a couple ways to do this. If you have individual data points, then you can do a propagation of error. I know you did this in Physics 126 and Physics 127. It's also in your Physics 126, 127 lab manual. If you all say that you don't know it, I'll be happy to put up a discussion of how to do propagation of error. If you have a figure where your result is the slope, then there are two ways you can get uncertainty. You can get a statistical uncertainty by using, I should write this out, uncertainty using LinEst in Excel. And LinEst is not terribly easy to use, but notice this will only give you a statistical uncertainty. Just as important, put on error bars on your data and ask, what are the steepest and shallowest lines that work for your data? Your steepest line and your shallowest line then should give you a range of values that are themselves an uncertainty. Finally, remember that in quoting uncertainties, oftentimes what people do is they give a value plus or minus the statistical uncertainty plus or minus the estimated systematic uncertainty. So you might, depending upon how your results go, you might put those on. One thing I forgot, by the way, when you're doing individual data points, you have to do propagation of error. You can also do standard deviation. Notice a standard deviation is a purely statistical uncertainty, just like LinEst is a statistical uncertainty. Propagation of error takes your estimated uncertainties and gets you an estimated systematic uncertainty in the same way that your steepest and shallowest lines give you an estimated systematic uncertainty. The goal here, of course, is to compare your value with compare your experimental value plus or minus the uncertainties versus the accepted value. If your experimental value with the uncertainties contains the accepted value, then things are looking pretty good. If they're wildly different, then we've got a problem. So just general comments regarding the lab report. Make sure you label, title, and caption all your figures. Make sure your tables are formatted properly, and then make sure that you do a reasonably decent uncertainty analysis, because remember, numbers by themselves without uncertainties don't mean a whole lot. Look at the 2016 US election for evidence of that. I hope you have a great day. Stay healthy, And let's end with a little more Carrot Allison in French.
Nous verrions tous les deux ensemble, toi qui m'aimais, moi qui t'aimais.